Hello, everyone, and a very warm welcome to Kognito Key. I'm absolutely thrilled to have you here today. We're diving right into the secrets of an invisible yet incredibly powerful force that surrounds us every single day. We're going to unlock the fascinating world of magnetism, and specifically, we're going to understand magnetic flux. Today's roadmap is quick and packed. We're covering what magnetic flux is, the math behind magnetism, closed versus open surfaces, and the fundamental properties of magnetic lines. Let's get right to it. Section 1. What is magnetic flux, and how do we visualize the invisible? Let's start with a really clear definition. By definition, magnetic flux is the net number of magnetic lines of forces set up in a magnetic circuit that pass through a given surface. Think of it like a magnetic wind blowing through an open window. The total amount of that invisible wind passing through that specific window frame, that is your magnetic flux. To make this super concrete, let's compare it to something you likely already know, an electric circuit. Just like electric current is the active flow of electrons through a wire, magnetic flux, which we denote with the symbol phi-m, is the flow of those magnetic lines of forces through a magnetic circuit. They actually behave in incredibly similar ways. Now, if we're going to calculate this, we need to know the units. In the standard SI system, we measure magnetic flux in Webers, abbreviated as WB. Fun fact, that's named after the co-inventor of the first electromagnetic telegraph. And if you're using the older CGS system, the unit is the Maxwell. Definitely keep these specific units in mind for your calculations. Moving right along to Section 2, the math behind magnetism and calculating that flux. So here's a really interesting challenge. How do we actually measure something completely invisible? We know the flux is there, but how do scientists and engineers put a precise number on it in the real world? The answer is a brilliant little device called a flux meter. Now, it doesn't just magically see the invisible lines. Instead, it uses a measuring coil. As the magnetic flux changes, it actually induces a variation of voltage right inside that coil. The flux meter picks up on that exact voltage variation, and from that data, it calculates the magnetic flux. It's elegantly translating the invisible magnetic world into measurable electrical data. And here's the mathematical heart of it all. For a constant magnetic field, calculating the flux passing through a surface boils down to three main things. B represents the magnitude, or the sheer strength, of the magnetic field itself. S is the area of the surface the field is passing through, and theta is the specific angle between those magnetic field lines and the perpendicular normal to the surface area. Please don't let the math intimidate you. It literally just means the total flux depends on how strong your magnet is, how big the window is, and the exact angle the magnetic wind strikes that window. All right, Section 3, closed versus open surfaces, and what we call the zero rule. This is a strictly enforced rule of physics you've got to remember. Imagine a completely closed surface, like a sealed box or a sphere. The magnetic flux through that closed surface is always zero. Why? Because every single magnetic line of force that goes into the box also has to come out. They perfectly cancel each other out. But if you have an open surface, like a flat sheet of paper, the flux is definitely not zero because those lines just pass right through from one side to the other. Always keep that zero rule in your back pocket. Finally, we arrive at Section 4. Properties of magnetic lines, or as I like to call them, the rules of the road. There are 4 absolute, unbreakable laws these invisible lines obey. First, magnetic lines of forces always form a continuous, closed loop. They never just vanish into thin air. Second, outside of a magnet, they always start their journey at the North Pole and end at the South Pole. Third, and this is absolutely crucial, they never, ever intersect each other. If they crossed, it would mean the magnetic field has 2 different directions at one single specific point, and physically there's no way that can happen. And fourth, if you have parallel magnetic lines of forces traveling in the exact same direction, they'll actively repel each other, pushing themselves apart. These 4 rules dictate literally everything about how magnetic fields behave in our universe. And that brings us to the end of today's explainer. But before you go, think about this. Every single time you flip a light switch or charge your phone, you are relying on these tiny, invisible magnetic loops spinning inside massive electrical generators. The invisible literally powers our visible world. If you found this explainer helpful, please hit that like button, share this explainer with your peers, and make sure to subscribe to Kognito Key for more structured, fascinating insights. Keep unlocking knowledge with us, and I'll see you next time.